All right, good afternoon. Let's get started. So this is one topic that I really think it's important because this is one of the things that you're seeing more convergence of, and there's the issue of, I think this is one of the ways that you can take the technology and being deployed, right? It's the notion of, people are excited about it because it's the next step from the way you get your television and other entertainment programs, right? So we've been traditionally used to broadcasting television off the air, and as people move more and more towards off air and towards things being given to you at home, right? Cable TV and satellites was the next generation, right? So you were able to get the TV program into your house, right? So the excitement here is now with the technology, I can send one wire into your house and give you telephone and video and internet access, right? And so in fact, if you look at the AT&T UVerse, which luckily is available in our market, they sell this as this is a way for you to get, they call it UVerse voice, UVerse internet, and UVerse TV, right? So UVerse voice is presumably voice over IP, and UVerse internet is your regular DSL, and UVerse TV is this TV coming through to you in IP form, right? And so from AT&T's perspective, it's really good because they would like you to get this $200 a month package, which includes all the services to you. So they would like to send you 360 channels, 18 megabits per second, downstream, DSL, what have you, right? So in one swoop, they have the market for your TV and your telephone. Though it's not clear to me how relevant the voice aspect of it is, because the trend is towards people using cell phones and all those things, right? But the trend is for people to have TV service and you get this stuff, right? So that's what they want to do. In a larger scheme of things, this brings into question a lot of issues that are unresolved or are in conflict with each other, right? In all these systems, there is you, there's the ISP, and then I say it's the owner, right? So owner is the one who has the content that you want to look at. It may be TV, it may be movies or what have you. And you is obviously you, and ISP is somebody in the middle, right? The tension is so you want to keep the dollar low, right? Everybody else wants to share up the dollar, right? And there is a number of different ways where all these guys interact with each other, and we call them different technologies based on who gets to be where, right? You are always at this end, right? You don't particularly care how things come to you. So from your perspective, you don't particularly care whether it comes to you after you pay some amount to ISP, after you pay some amount to the owner, right? So for example, if you'd like to get the movie, and let's say you pay $5 to download it, you don't care who gets the money. As long as the cost is okay for you, you're going to do this stuff, right? So this is the sort of the global world of where things are. One of the ways so how would you now distribute the content? So suppose you have a content here, right? You are free to ignore the ISP, right? How would you distribute the content to the end user? What kind of technologies you can think of? We sort of mentioned this a little bit before, right? One is the notion of centralized server kind of stuff, and the other is a peer-to-peer stuff, right? So centralized stuff, you go to the owner, and the owner gives you the content, right? The owner also may have other things called CDNs. So you go, and then the owner actually sends the content back from you. So you're kind of going and getting the stuff from the content provider. So you're paying certain amount of dollar to the owner, right? And you're paying a certain amount of dollar to your ISP in terms of cost like this. Right? So this is one model you would like to go where you're paying everything to the owner. The ISP gets nothing other than the access fees, right? You may agree or disagree whether that's a fair cost that they should get, but that's what they get, right? But ISPs would like to get into the action too. They don't want to have to give away 18 megabytes per second and have all this stuff go to the other one. So they like to get involved. And so they like, the way they respond to that is trying to put caps on how much you can download and stuff like that, right? If you want to ignore this owner, if you don't want to deal with this owner, one way to do that is to have peer-to-peer technologies, right? So where you can have another you who kind of took this content, and then they can deliver the content to you, right? So if this was stolen, right, then owner does not get any cost, and of course there's all the lawsuits and stuff. Or you can imagine the owner giving some little bit kickback to the other person to service you, right? So one way to do that is, the piracy way is easy because you don't actually pay anything to the owner. You get the latest movies before they were even released, and you put it up over here, and then you download it. There's all the P2P applications like Nutella and Napster and BitTorrent and all those things where you get the content, and these people don't get paid, so they sue. So let's stay legal, right? So in a legal fashion, it's possible for them to sort of give a little bit money to the person, right? So the owner can say the movie costs $5. It'll still cost you $5 for you to get, but now I'm going to keep $4. I'm going to give $1 to this person, right? That's one sort of incentive we can do to get this stuff, right? It may be built into your system in either you may be aware of it or you may not be aware of it. The way you are aware of it, if they actually give you a kickback, they actually say, somebody downloaded this much content, so I'm going to give you $1. You may be unaware of it because as part of you running this application, they can do whatever they want. They reduce the cost, right? So they can say, the movie would have cost $6 if I didn't do this stuff. So you see, hidden from you, as part of you running the system, you have to be part of this stuff, right? And the reason why you may do that is, it may be too expensive for the server to service the content to you, right? So they're shifting the cost of delivery away from themselves to you and letting you deal with the ISP cost, right? Rather than pay the cost here, they're hoping that you would pay the cost here and they don't pay the cost. So they're trying to figure out how these things work out. So that's the constant battle, trying to figure out where to shift the cost where you can keep the most of the money, right? In all these schemes, whether it's directly from the server or from the ISP, like from the other users, ISPs don't get involved, so they try to stop this as much as possible, right? And so the IPTV stuff, so the examples of this kind of a systems are, let's call it internet TV, right? And examples are the PP Live and Juiced and stuff that I think you saw a demo of the Juiced, right? So essentially these are stuff where it's coming from somewhere else. The ISP has no notion of what's going on. Whereas the one we're going to talk about, IPTV, essentially you have owner is, say, AT&T, right? Or AT&T paid the appropriate fees to the content provider. The ISP is AT&T, and you are a customer of AT&T, right? So they control everything. So there is not much of the issues of who to pay, quality of service, and all those things, because it's all within their own network. So they can get you better quality of service and all those things. And we'll see, what can be done here, right? So this is a much better world than this one, right? From your perspective, because here ISPs are trying to not help you because they're not getting the extra money to do this stuff. So you as end user and the owner have to run circles around the ISPs to make sure that you can get the good service, right? So quality of service, getting a quality of service is pretty hard because really speaking, you want to get quality of service. The owner wants to give you good quality of service. ISP does not want to give you good quality of service unless you're willing to pay more. And you don't want, the argument would be, I'm already paying $200. Why do I have to pay more to get you better quality of service? Whereas here, it's owned by the same entity, and they want to make sure that you get the best quality because they don't really have too much motivation not to give you, right? And the other thing we'll see is, even in this scenario, it's not possible always to have the server server to you being able to support what you're trying to do, right? It makes sense to use peer-to-peer technology, which is what some of these things are trying to do to reduce the cost, right? But in this case, reducing the cost hopefully is passed on to you because AT&T is owning the whole thing, right? So if AT&T can build a technology where using peer-to-peer, they're able to reduce the ISP cost, they're able to reduce the amount of cable they have, they can hopefully pass on the cost to you, right? Do you believe that they will do that? Do you believe that if AT&T, so they own all this infrastructure, right? Suppose you deploy a peer-to-peer scheme where you download something from your neighbor, which means that AT&T did not have to upgrade this line. That means they saved some money, right? So do you think that they will pass on the cost to you? Depends on how cynical you are with the ISPs, right? But this is the best we can hope to get. If you're cynical about this, you're going to be a lot more cynical here, right? Because here the ISP don't even want you to do that, but here they can do something, right? So that's the stuff, So this is not that different from the internet TV, because even internet TV, you're taking the TV program, you're digitizing it, you're sending it in MPEG-4 or what have you. You may send it as a distributed server, or you may send it as a peer-to-peer approach, right? And if you're talking about illegal stuff, peer-to-peer has a nice ability that I don't have. I can do it clandestinely and send the content, right? So let's ignore the illegal part. Even for the legal part, having a distributed peer-to-peer approach helps the owner because they can reduce the cost of distributing this content, but it doesn't do anything to the ISP. Whereas here, ISP is the owner, so they have motivation to make sure that these things can happen, right? So they can do a lot of stuff because they know exactly how things are. They know exactly that this is using 1 MB, this is using 2 MB or something. So they know precisely how much these things have to be. So they can we'll see what they can do with those kind of stuff, right? And turns out if you use whatever you do on the systems over here, you would perform poorly, and that's one of the other important things you need to take away from this. Because in a traditional networking scenario, you don't actually consider the network topology before you build these things. You know it's out there, but it's kind of hard for you to probe and figure out what's going on, right? What I mean is, I'm going to erase this stuff. I'm not sure precisely what the Notre Dame network looks like today, right? At least like a few months back, what we had was we had the ND campus. We had a 200 megabits per second link from our campus to Chicago, right? From there, it goes off somewhere, right? And we have peering agreements with other people, so the picture sort of gets muddied. What I mean is, so Comcast, let's say, is here, right? So they have their own network across the country, right? But we have sort of a peering agreement between our two institutions, because otherwise, if you don't have a peering agreement, what you do is somewhere there's a Comcast Chicago, and we sort of link like this, right? So from your home to school, so you may be living right across the street from school, you would have to sort of go to Chicago and come back here, right? So St. Mary's actually would be here, which also came through somewhere in Chicago, right? Things get muddy because there's a lot of aggregation going on, a lot of ways happening. But essentially, we had one of these links, and then we had all the stuff, right? So when you're talking about peer-to-peer systems, we talk about getting stuff from your neighbors, right? The whole notion of peer-to-peer is you don't want to go far, you want to go somewhere closer, right? Because the assumption is if you want to get some content from California, instead of going to California, it's good to go to somebody in South Bend, right? So that's the high-level logic that you want to use, because the assumption is this is probably cheaper than going there, right? But in terms of what it actually happens on the network, it's not that clear, right? What happens is your neighbor may be living across the street, but to get to them, you have to be aware of this network topology, right? So a person who's near to you across the street and the person who's like sort of like 10 miles away from you, 10 miles away from you may be within our campus, right? But a person who's across the block from you, you may have to go to them by going through like this and come back, and the request may go this way and may come back over this link, right? And this link is not all that big, right? If you consider our campus, right? 200 megabits per second is not all that big because most of our Ethernet ports are gigabits per second. So if you let you use it, most of you can use one single laptop hooked up to one of the Ethernet ports and swamp this network. Of course, you can't. I mean, there's enough stuff along the way that won't happen, but it's not that much, right? So what happens is, you try to evolve the systems to avoid this stuff. So if I tell you that this is what is happening, you would like your system to not use somebody from South Bend because they're pretty far. Actually, people from Chicago may actually be closer because we have to go here and come back again from Chicago to South Bend, whereas if you use the regular link, you may not have to come back, right? And that becomes very hard from within the network because there's not much you can know to find out this topology, right? This is a topology I said we had a few months back, but the operators are constantly shifting how these things are done, and so things may not exactly look the way it is. But when you build the application, you don't have all this knowledge, you don't have all this stuff. So peer-to-peer in the global sense sounds good. In a practical sense, it's very hard because you don't know the topology. You're trying to figure out what the topology is. So ideally, you would like to use all the people in Notre Dame for all your services and not anyone outside, because hopefully this accessing somebody inside here is fast and cheap, right? What's the cost of doing that? What's the cost of us using just people within our campus to do? How many of you use any kind of peer-to-peer stuff knowingly? I'm saying knowingly because a lot of the things you may not realize you're doing this because the system itself application itself may do that, right? So what would, is there anything against like using just people locally within you? What would you use the peer-to-peer stuff for? So one of the things that people use that is to like say download music, right? Let's call it download and not pirate, right? So download music, right? So what would happen if you only look at contents from within the campus? What do you think would be your experience? Yeah.
You might not have much variety.
Yeah, variety, right? Because if you use just the network conditions, then you may not have much variety and stuff, right? Variety, much robustness, much stale contents, all those things. So you would like to go outside. So mixing all those things becomes harder, right? So you would like to get fresh content from outside, but you also want to be network aware, right? And all you have is ping and all those things, which won't capture all the stuff happening, right? Ping will tell you that from here to Chicago is pretty fast, right? Ping may say that from here to Chicago and back is pretty fast, but it doesn't say that you only have 200 megabits per second here. So if you use this, you're saturating, you have a bottleneck here, all those things, right? So the things like Juice and all those things which are using these kind of technologies have to fight with this stuff, and depends on, so if you use one of those applications, sometimes you're happy, sometimes you're not happy, and it's very hard to debug what's going on, it's very hard to figure out what's going on, and that's one of the things that those systems run into, right? It's sort of okay for things like downloading music and stuff because the network has gotten fast enough that music is not a big deal. Video and all stuff, you may notice that there's a quality degradation, right? The other trend in this model is if you live on campus, you won't notice this stuff, which is the asynchronous nature, right? What it means is if you have somebody who's living here, right? So even within the AT&T stuff, right? They're giving you like 18 megabits per second. that's the download stuff, right? So the network to this house can be Mbps, and I think the cheapest they have is 3 megabits per second, right? From the house back, I think the biggest that AT&T gives is 1 megabits per second. It could be, I think, 128 or 256, right? Which means that if you're using a peer-to-peer approach, right, I can consume a lot more than I can give, not because of me, but because of the network, right? So somebody who's close by, they may be close by, they may have the content that you want, but they can't service the stuff, right? Do you know why this asynchronous nature? You may have covered this in networking class, right? Yeah?
Because most home users don't really need to upload a lot. If they're just downloading web pages and things to send pretty small requests outwards.
Yeah, that's an excuse, right? I mean, that's an excuse that they tell you. So I'll put it this way, right? If I gave 18 megabits per second down and up, right, the customer won't complain, right? I agree with you that the users may not need the download stuff, right? Upload stuff.
It could cost them money to give them all that upload, so why bother if they're probably not going to use it?
Yeah, so it could be that it costs money, right? But if you think more about it, right, it may cost them more to give you that upload bandwidth, right? Same upload bandwidth. But more importantly, the upload bandwidth, you're going to use it, like you said, it's not like people are only downloading. It's like people should be downloading, right? We don't want people to be uploading, because uploading means that you're going to do this service, right? You're doing this peer-to-peer service where the owner, in this case, somebody who stole the content, or could be owner or what have you, are making an end run against the ISP, right? ISP has no motivation to let that happen, right? So there's a technology limitation which makes it that they cannot give you all the stuff that you may want. But on a more practical business, like I said before, the owner wants to do this, you want to do this, but ISP has no motivation to help you doing this, right? Because they don't want you to upload content. They can say, if you have 18 megabits per second downstream, you can get all the content because that's approved by them. They don't mind if you download something from the internet. They don't want you to be uploading. They don't want you to be helping others, right? So they would like to say it's sort of the technology problem. It is a technology problem, but inherently they have no motivation to give you more than the bare minimum, right? Because this is not something that they want to approve, because like I said, they're not getting paid for it, right? But it's the same here, right? In the case of, again, they only give 1 megabit per second, right? So they only allow 1 megabits per second upstream, 80 megabits per second downstream to the user for the DSL service. But they can internally sort of relax the stuff. So if you are going from here to here, and these are both AT&T users, it's very possible for them to kind of relax that link, right? So they can actually let you download or upload something from your neighbor who also happens to be AT&T customer, and they can give them, so they can allow you to do 18 megabits per second, whereas only 1 megabits per second can get out of their service to go somewhere else. But within their own service, if you're going to get it from your neighbor, the neighbor can upload 17 megabits per second, just because it's going to help the ISP. Because you doing this helps the ISP because they don't have to use their own network over here, and that helps them. So that's one of the things that becomes different here. They don't have to give you that 80 megabits per second downstream and 1 megabits per second upstream for their own IPTV service. So for the IPTV service, they can do whatever they want. But for the DSL service, they put this restriction, right? So the restriction is not necessarily technical, but this solves the problem of motivation for why they want to do this service, so they can do better things than what can happen here. So where P2P would fail here, because you can't, so if you want to download a HDTV movie, which happens to be around 6 megabits per second MPEG-4 quality, right? So if you have only 1 megabits per second, or I think nominally 368 kbps or something, right? So you need a whole bunch of users to get high definition quality, whereas here they can change the game so that they can get better quality, right? So that's another thing which changes here. as opposed to here, because ISPs are involved. ISPs want to make sure that they can get the most bang for the buck, and they get direct money for it, right? So that's another important thing to notice with these services. And there's one other point that I thought of something else, but so that's the stuff, right? So there are two big operators in this space, and I'm sure all the other operators are also getting into it in some sense, right? The two one are the AT&T, which is a XDSL based scheme. So essentially that scheme gives your home 25 megabits per second and 1 megabits per second upload, right? And again, there's no reason why it has to be 1 megabit per second. And again, there's no reason why internally they have to leave it at 1 megabit per second. But that's the only thing you can give it to other users. Verizon does the Fios, which is a fiber to your home. So the way the AT&T thing works, I think they call it FTTN. It's a fiber to your neighborhood, right? So the way DSL works. So if you have your home, right, you have this DSL box, right? So you have multiple houses connecting to this thing, right? And so essentially, this 25 megabits per second is what they can give from here to here, and there's limitations of how far this can be, right? I think it's like within several kilometer or several couple of miles, 1 or 2 miles range, right? So you connect all this stuff, and from here, it's a fiber, right? Fiber optic cable, which has a lot more bandwidth than you can imagine, right? Then you can want for your house. Whereas the Verizon Fios, it actually drops a optical cable right to your house, right? So you can get gigabits per second network to your home. You don't have to go through this stuff, right? So going through this gateway adds more restrictions, because that restricts how much bandwidth you have, and it shows you how much bandwidth you have. And with the fiber optic stuff, you get the maximum bandwidth. So they're sort of future proof. I mean, they can deliver gigabits per second to your home. The cost of doing this is pretty expensive. I think I mentioned in last class. The estimates are on average, I think it costs them like about $1,500 or so to do this, right? Because the expensive stuff and all this networking technologies is the digging part, right? You have to dig this stuff and then put this in. So the cost of adding new services to existing infrastructure is a lot easier than laying new wires, right? So in the case of DSL, you had your copper telephone cable, so they're just adding something onto it. You probably cannot go too much further than what you have. So the AT&T model is sort of like a dead end, whereas the Verizon model, you can sort of go up to a limit, right? So this again goes into networking. So some of the reasons why. So for example, a lot of cities, I think including South Bend, they run their own citywide networking infrastructure using optical network, right? And one of the popular ways, so most cities run optical cable for the traffic light signal, right? I forget why, but I think it has less interference or what have you. So the traffic lights run optical signal throughout the city, right? And they laid out the cable at some point, right? So now they're figuring out that the traffic lights are not that data intensive, right? I mean, it practically changes every second, every few minutes, a couple of times, right? So they're renting those cables out for data service, because other times you can get like gigabits worth of network, and you get enormous savings because of the fact that this was laid by the cities, right? So all I have to do is connect into the city network, and I have gigabits network around the city. I think South Bend calls it MetroNet, and different cities do different stuff, right? The other place where one of these things are used is the train service. It's called the Abilene, right? So the train service, for the signaling, they use optical cable because you don't have to boost the signal often. So that was the first way to get Internet 2 up because you had trains rode. So wherever the trains went, they had the optical cables signaling that little, the train lights and stuff. So you can use that for data service, right? Again, there's offshoot, but essentially that's where the technology comes in, right? So you figure that, I think the AT&T model, they say they sell like 290 or some odd channels, right? So they would like to deliver that many channels to you, but the real action, the channels you pay for it upfront, there's nothing much they can do about it. The other action is in video on demand, right? Video on demand is one technology that's been around for a long time from the cable services on kind of stuff. And that's one area where they would like to make more money because they can deliver movies to you on demand and make money, right? So video on demand is the pay-per-view kind of thing. So you can think of them as a periodic model, right? Where every 15 minutes or something, they keep broadcasting the same movie, right? So they can kind of time shift. So if the movie is popular, they can keep broadcasting the same movie starting every half an hour or so. So you have some movie starting every half an hour kind of thing. So that's a pay-per-view model. Or you can have true video on demand where you go in, you want to watch a movie, you can get the movie at any time. And depending on how convenient it is for you to go to the DVDs, to the Blockbuster or watching the stuff, that's where the money is. So we'll look into more of the video on demand, not necessarily on the pay-per-view kind of stuff, which is different, right? So the usual stuff is MPEG-4 HDTV program requires about 6 megabits per second. Normal definition would require 2 megabits per second. So if you look at this, right, there's no way you can deliver 300, 400 channels to your house because you only have 25 megabits per second, and I can't deliver 6 times 350 or 400 channels, which is pretty high, right? So what they do is they multicast this service, right? So AT&T is multicasting, let's say, 400 channels, and you as a home user, right, when you're watching a channel, you have to subscribe to a particular channel, right? Which means that somewhere along there are routers along the network, so you have to tell all of them that I'm going to be interested in this particular channel. So the packets from that particular channel will be routed towards you, right? And you're watching this channel. Then if you switch your channel, you have to send information along this route to say, I'm not interested in this one, I'm going to be interested in the other channel. So they have to get routed back to you, right? So the packets from the old channel would have to be let go, the new one has to be done. So depending on how the network is set up, the tree that you so it essentially becomes a tree, right? Your neighbor may watch a different channel. So depending on how the tree is set up, in the worst case, the network bandwidth here has to have capacity of 400, right? In the really worst case, everybody above your home has to have 400 megabits per second because you can, depending on how many channels you can watch, right? So you have to, so you do the math to figure out what the network, right? So the video on demand runs on top of the stuff. So we have to be all these things plus the video on demand where it's not one channel. So I may decide to buy a movie at this instant and they may start delivering it to me, and my neighbor may want to start watching the movie 5 minutes into the picture, and they would have to start delivering it to them. The peer-to-peer stuff comes in because if I knew that my neighbor is watching the movie, maybe I can do something, right? Maybe I can do something to get the stuff from them, and that's why the peer-to-peer comes here. So in your set-top box in the case of IPTV is doing this multicast switch. So if you get a chance to go to the AT&T store, right? They have a simulation because they couldn't show this stuff. They don't want to show this stuff, right? So the inherent problem with IPTV systems is if I change a channel, right? All this has to happen. It's not like the signals are coming to you all the time, and your local set-top box is changing its tuning, right? So when you had the old cable TV kind of stuff, when you change the channel, it's the time it takes for your own TV to change the tuner to a different one. So you can change it pretty quickly because it's basically not doing too much on the stuff. Whereas here, if you change a channel, something has to change so you can get this stuff, right? So one way you can kind of mitigate this stuff is I can kind of keep downloading the next channel up and down. So I can be receiving signals for the channel one above and one below, right? But that's incredibly wasteful because that means that I'm wasting all the stuff. But that's one way to hide the latency. But essentially, the problem here is if you change the channel, something has to go all the way up or all the way enough levels such that you can get the new packets. And for during those times, you cannot see any picture. So it's slow, right? So that's one of the things that I was asking, like how they're like, if you go to the store, they tell you like it's a really good picture because you get like really high definition, it's all fantastic and stuff. But that's not the problem, right? If you're going to do a 6 megabytes per second, it's not surprising that when you have 25 megabits per second to your house, a 6 megabit per second high definition TV would come to you, and high definition TV looks good. But the real challenge is the channel changing latency, right? But what you really want to do at least for the video on demand, if I can use my neighbor's stuff, then I win, right? And this is the example of any peer-to-peer stuff. I can use the neighbors and all those things, right? So now within the two neighbors, in a pure peer-to-peer system, it's not clear why they should help you, right? So there is your neighbor, and this is you, right? Why should the neighbor help you? Right? So for you, it's good, right? So instead of going all the way across, if you can get from a neighbor, it's really good, right? Why should they help you?
There's no real reason to. All they're doing is sucking up their upload bandwidth.
Mm-hmm.
I mean, maybe like some sort of, if I help them, then maybe they'll help me in the future. There's not a lot of real benefit.
Yeah, so that's called a tit for tat, right? That's sort of what BitTorrent and all uses, which is, you hope that if you're nice to somebody, then they'll repay it back, right? And there's a whole area of research trying to kind of figure out what that means, right? Tit for tat is essentially, I'll do for somebody that, whatever I got from somebody. It's not that trivial, right? Because I may not want to give somebody, so a bit is not same value every time, right? I may be doing something else. So I don't want to really help you, and so if I downloaded a movie right now, and at 4 in the morning when nobody's home, you're downloading, uploading stuff from me, right? So should I give you more bandwidth because I'm not using kind of stuff, right? So it becomes kind of tricky. But here, since AT&T owns all this stuff, they don't even have to ask you, right? They can sort of do it without really asking stuff from you, right? So one of the other problems with the peer-to-peer is you not only have to worry about your bandwidth, you're also giving me your storage, right? Because you have the content that you're trying to give it to me, right? So it becomes an issue of what does this object mean, right? So for example, if you're watching a movie, right? Once you watch the movie, you may not particularly care for it, right? So you don't want to leave it around because you watch the program, so you're done with it, right? But that's the one that you want to give to your neighbors because you're not going to help your neighbor about a video that you haven't watched yet, right? So what you're going to help your neighbor is use your storage to serve a content that you already watched, which is no use to you, right? So inherently, you want to get rid of it, right? But your neighbor only can use that. So you're losing your storage, you're losing your network bandwidth and stuff. And so some of the studies which done looking at the way the peer-to-peer systems like BitTorrent and all are done, right? It turns out most of the ones which are actually serving contents happen to be at, do you want to guess where they were? So peer-to-peer, I'm supposed to get somebody from my peer, right? Like I said, across my street or something, right? So if you look at who the other person is, not me, right? Who the other person is, right? Where do you think the other person is most likely to be? A cafe, like an airport, a business, or a university, or something else. Where do you guess they would be? Who do you think would have lots of bandwidth and don't particularly care about the cost of uploading?
University.
Yeah, university, right? So peer-to-peer, if you look really closely, it's essentially subsidized by university users, right? Because students don't really see that they're paying for the cost of internet, right? The 200 megabytes per second for Notre Dame, I think it's like $20,000 or something a month, right? It's not like the money we are just printing somewhere, right? I mean, you guys are paying for it from your tuition, right? But the cost is not very apparent to you, and the incentives for you not running a BitTorrent in your office, it's only the how far your university penalizes you, how far they react against you, right? So as long as somebody doesn't complain against you, you don't see the cost of running this service, right? Whereas if you're running it at home, you lose bandwidth and stuff like that, right? So these services sort of exist because university. So when people talk about peer-to-peer, think of it's really the university is doing a public service for all the users, right? But otherwise you would care if you're in a home and you are running this BitTorrent, you would care because your bandwidth cost goes up, and AT&T directly knows. Even if they don't care about what content it is, they can say you've been using a lot of bandwidth and stuff, and you're using storage and all those things, right? What they can do in this setup, they can do the same thing, but when they give you the set-top box, they can say we will use a certain percentage. Let's just arbitrarily say 10%, right? 10% of your disk, you won't see it, right? You cannot see it. We'll use it for others, right? And all these systems, they essentially do that. So when you get a service with them, you're subsidizing this by essentially giving up some storage, right? You're happy with the other storage for whatever you want. So when you ask for a video on demand movie, they use the rest of the storage for you to store the movie and then play it from your disk. But you're also storing some of the content into your disk and giving to other users, right? And there's other line of research which figures out what should go there, right? So if they can place something there that you're going to be using tomorrow, if some movie is going to be very popular, if they can place it on strategic locations within the system, then they can maximize the way thing. So in this system, the AT&T can know what you're watching. AT&T can know what you watched forever. They can know what your neighbors watch. They can do massive data mining on all the systems. Then they can figure out that, for this particular community, you're all going to watch some movie tomorrow. I need somewhere to keep this. I don't have to go for any CDN or something. I just know that within this community, you're the one who's going to wake up in the morning. You tend to wake up and watch the movie at 7 o'clock, and he tends to wake up at later. So I'm going to use your cache. I'm going to use your 10% cache so I can service him. So they can do all this kind of crazy stuff to get very good quality because they don't have to ask you, right? You have no motivation you have no choice to disagree or agree with this stuff. You just give your disk. So they solve the problem of incentives directly. This particular paper actually talks about what kind of incentives they can give you. I'm pretty skeptical of those because I think the right model here is AT&T does not ask you, right? So if you have any of these services, you never see somewhere where AT&T says, I'm going to use X% of your disk, you cannot complain, right? And they're going to use some percent of your upload for helping your neighbors. If it is within that, above the 1 megabytes per second, you don't notice. If it's below that, you don't usually have much control over that either. So if they say you can have upload of 1 megabits per second, but if they use half of it for your neighbor, you can't really complain because if you ever complain to the DSL services, if you look at the end user agreement that you sign when you sign up for a service, right? Which basically says that AT&T will promise you that you'll not get more than 80 megabytes per second, right? Which I don't think anybody would really complain if they give you more than that, right? But they never promise anything what's the minimum, so they can do all this stuff, right? So that's the thing. So in the larger context of schemes, I think the real P2P, a lot of research is done on the true P2P, internet TV kind of stuff. Things become a lot more harder, but it's not clear how the different operators come in play and what the incentives for those systems are. This is a system where the incentives are clear. Somebody has absolute control over what things can happen, and these systems can work. And in fact, they do work. I mean, AT&T is charging you for $200 for that particular service. and they cannot do that all by themselves, right? So the traditional P2P systems assume the internet to be some sort of a cloud, and they try to figure out what the cloud is by doing pings and all those things, but essentially they don't know anything about what's inside, right? And the beauty of the systems is you don't know what's inside, and the thing which makes these systems hard to work is you don't know what's inside. Whereas in the case of this is the folks from AT&T who wrote the paper. So they know what they have, right? So I don't know if you can see it. So essentially these are the homes, and these are the set-top box that you have in your home. And this is the FTTN on your neighborhood. And within your city, you have some sort of a local video server, and then you have a national video server. And so this link from a neighborhood is 24 gigabits per second. 24 gigabytes per second download and 1.244 upload, right? So this is also so from here to here, it can download 24 can go this way, only 1.244 can go up, right? And super high ends have sort of a lot of network bandwidth. From your local to the national one, it's a 1 gigabits per second link, right? So essentially, from here to here, from your local office to your neighborhood, you can get 24 gigabits per second. From your local to the local office, you only get 1.2. So let's assume this is for a South Bend, right? So for South Bend, each one of these neighborhoods can upload 1.24 gigabits per second. But from here to the national one, you only have 1 gigabits per second, right? So that means when you develop a peer-to-peer system, you can't just choose any peer, right? You want to choose your peers who are within this local switch, because that will give you, so essentially that's the 25 megabits per second that you're sharing, right? But if you want to share use somebody over here, right, you have to go to your local FTTN, to the local video serving office, to the local FTTN, right? So you're using this bandwidth and this bandwidth, so they can tend to add up, right? So when one of the things become a bottleneck, then the whole system fails. So you really have to choose your peers to be within your tree, not across the tree. But since you're AT&T, you sort of know everything which is going on. They can do these schemes. But if you don't know this stuff, you can do a lot of stuff that you couldn't have done if you didn't know this stuff, right? And so as you can see, if you do the math, right, you can figure out how much they can serve. So this is only 1 gigabit per second, right? So if all of you are begin to watch a new movie which has never been seen before, this system cannot handle that, because it's not possible to download all that much here. But if you can, so if AT&T can predict that you're going to do that tomorrow, it can upload it over here, right? Really, what they can do is they can upload it all the way into your set-top box, and essentially you're getting it from your neighbor. And as long as AT&T can predict those stuff, they're good, right? Because there's no way they can do video on demand by you going all the way across. It's a fascinating paper. I think you should read that. It's essentially easy to read because it essentially talks about how the topology is set up. And the nice thing is, they have motivation to make sure the quality of service is good, because it's their system, and they make sure. So some of the issues of how you would do the stuff, and turns out if you don't know the stuff, things will fail, and which is intuitively obvious that it'll happen. And so if I can use some of my neighbor's stuff, if I can take away 50% or so, then for my 6 megabit per second, I would have to get 12 peers who can give 500K each, right? But since I'm AT&T, I can schedule this stuff. You as end user do not get involved with the stuff, and you can and they basically do a striping. They basically get from the different neighbors. A lot of the problems go away, right? The problem with the regular peer-to-peer is I have to figure out who has the content. I have to search and all those things. Here, none of those happen because AT&T is the one who put the content with you. So they can tell whoever needs it where they should go. So indexing and all the problems that you can think of go away. They do long-term profiling, so they can know precisely what you've been watching for the last so often, and so they can predict what you're going to watch. more than that, they know how far you watched into a movie, right? So they can use that to do the system. So the way you can do that is you don't have to send the whole movie. I just upload like first half hour with a lot of people. In case you go beyond that, you are the special case, so I can send you the special, I don't have to waste my storage for a whole movie because this movie is so awful that people don't go past 15 minutes or so, right? They actually use that. I mean, they figured a lot of these things. And UDP is good enough in this case because there's no reliability issues because this is within the AT&T system. So they don't have to worry about packet drops and stuff because if things work the way they're supposed to, they shouldn't have a problem. And if you do that, there's some graphs, and essentially this shows that they can service the number of clients that they want. And the incentives that they talk about in this particular paper is the built-in model, flat and usage-based. Built-in model is the one where I don't ask you. I just use it, right? The flat reward model is AT&T says if you sign up for this stuff, I'll give you $1 off, right? Usage-based, I give you $1 off based on how much you upload, right? I'm very cynical of whether ISPs would ever do something like this, share the cost directly with you, right? I mean, we'll pay you $1 off if you use sharing kind of stuff. But as you can imagine, if you think about it, things work some way, right? So, for example, if there's a flat reward, then they can actually use more of you. If they use a usage-based award, their motivation is to use a server because that's free for them, right? Only when they can't use a server would they use your neighbor. Whereas if it's a flat reward system, it doesn't matter how much they use, they'll use the peer-to-peer more. In the built-in model, they'll use the peer-to-peer the most because there's no cost to them. It's all the cost to you. And depending on, so they can do whatever. I suspect that they will end up using built-in model. I suspect that they will never tell the customer that your service is used by somebody else to help the system. But these are interesting things to worry about, like what's the incentives and all those things. But it becomes a lot more simpler here than in the general internet case because it's AT&T, right? And you trust them to do the right thing, right? Okay, I didn't get to this paper. So, the question I want to ask is how do you take this incentive stuff to, say, YouTube kind of stuff? And there's a paper which was analyzing what people do from UMass campus, and they're trying to figure out how to, what sort of incentives you have, right? So in the same case of the Notre Dame, we only have 200 megabits per second. So if all of us want to watch YouTube, right, after 200 users, we'll saturate the network, right? So it's good to have peer-to-peer where people nearby can help you, and what is the incentives and all those things was on that particular paper. But generally, incentives is what drives the peer-to-peer stuff, other than stealing. But piracy is one issue, and the incentives of why you want to do that is a big deal, right? And we are sort of out of time. I'll see you guys on Wednesday. No class on Monday.